Right now, above Iceland and above the northern coast of Spain, the sky is quietly getting ready to do something it has not done in 27 years. In a matter of weeks, in the middle of the afternoon, the sun there will simply go out. The day will turn to night, and the stars will come back while the clocks still say it is daytime. But that is only the beginning. Because in August of 2026, the sky over Earth does not put on one rare show. It stacks several of them almost on top of each other. A comet you can catch with a pair of binoculars, a total eclipse of the sun, a meteor shower under a perfectly dark sky, and a moon that slowly turns the color of dried blood. In the next half hour, I'm going to walk you through this month, event by event. I will show you exactly what to look for and when. And I will explain the real science behind every single one so that when you look up, you understand what you're actually seeing. Because a month like this does not come around often, and once it is over, we will be waiting years for anything close to it again. Let me start by explaining why astronomers are calling this an unusual August in the first place. In any given month, the sky gives you something: a bright planet, a quarter moon, maybe a minor meteor shower that most people sleep through. That is normal. That is the sky ticking along. What is not normal is having several major events land inside the same 30 days. And that is exactly what is happening now. Space agencies, including NASA and the European Space Agency, have all three of these dates circled on their calendars. A total solar eclipse, a meteor shower at its peak, and a deep lunar eclipse to close the month out. On top of that, a comet is passing through at the same time. Think of it like this. Each of these events runs on its own clock. The moon has its own rhythm. Comets keep their own schedule. Meteor showers arrive on the same week every year, like clockwork. Normally, these clocks are out of step with one another. This August, for a few weeks, the clocks line up. And when they line up, the sky stops feeling like a background and starts feeling like a performance. The first act has already begun. Because there's a faint visitor moving across our sky right now, and most people have no idea it is even there. Our story opens at the very start of the month, on the 2nd of August, with a comet. Its name is Temple 2. Astronomers give it a more formal label, 10P, Temple. It was discovered more than a century and a half ago by a German astronomer named Ernst Temple, and it is what scientists call a short-period comet. That means it does not visit once and vanish forever. It loops around the sun and comes back every few years. If you have never really pictured a comet, here's the simple version. A comet is a mountain of ice, dust, and rock left over from the birth of the solar system. When it swings close to the sun, the ice heats up and turns to gas. That gas and dust stream away, and that is what forms the glowing head and the faint tail we try to see from Earth. Around the 2nd of August, this comet reaches the closest point to the sun in its entire orbit. Astronomers call that point perihelion. It simply means the moment a comet is nearest to our star. That is usually when a comet is at its most active and at its brightest. The very next day, on the 3rd of August, it also makes its closest approach to Earth. At that point, it sits a little under half of the distance between the Earth and the sun. In plane numbers, that is roughly 62 million kilometers away, which is about 38 million miles. Now, here is the honest part, and I promised you honesty. You will not see this comet with your naked eye. It is not going to blaze across the sky with a glowing tail. Astronomers expect it to brighten to around magnitude 8, and that word magnitude is the key to understanding everything you will see this month. So before we go any further, let me explain what a magnitude actually is, because once you understand it, the rest of the sky suddenly makes sense. Magnitude is just a number that describes how bright an object looks in our sky, and it works in a way that catches almost everyone off guard the first time. The scale is backwards. The lower the number, the brighter the object. The higher the number, the fainter it is. This is not a modern idea. It goes all the way back to an ancient Greek astronomer named Hipparchus, more than 2,000 years ago. He looked up, sorted the stars into groups, and called the brightest ones stars of the first magnitude. The faintest ones he could see he called the 6th magnitude. That old system still runs our sky today. Under a truly dark sky with no city lights, the faintest star your eye can catch sits at about magnitude 6. Anything fainter than that, and your eye simply cannot register it. So look at where our comet falls. Magnitude 8. That is fainter than magnitude 6, which means it is just past the edge of what a human eye can do on its own. Lift a pair of binoculars, though, and it comes into reach. To feel the other end of the scale, think about the brightest things up there. The full moon shines at nearly magnitude minus 13. The sun sits at around magnitude minus 27. Those minus signs tell you they are overwhelmingly, blindingly bright. So keep that one rule in your head for the rest of this video. Lower means brighter. Higher means fainter. Because in 10 days, the brightest object in our entire sky is going to do something almost no one alive in Europe has seen. On the 12th of August, in the late afternoon and early evening, a shadow is going to race across the top of the world. It is a total solar eclipse. And a total solar eclipse is one of the most extraordinary things a person can ever witness in their life. Here is what is actually happening. The moon passes directly between the Earth and the sun. For a brief window, the moon covers the sun completely. Its shadow falls onto the surface of our planet, and anyone standing inside that shadow watches daylight drain out of the sky. According to NASA, the path of this eclipse crosses Greenland, then Iceland, then a stretch of the Atlantic Ocean, and finally sweeps into Spain. A small corner of Portugal catches it too. Inside that narrow path, the sun does not just dim, it vanishes. The temperature drops, birds go quiet, fooled into thinking night has arrived. Bright stars and planets appear in the middle of the day. And around the black disk of the moon, you can see the sun's outer atmosphere, a shimmering white crown called the corona. There is a single moment right before totality that eclipse chasers travel across the world to witness. As the last sliver of the sun slips behind the moon, it flares into one brilliant point of light, set against the ring of the corona. People call it the diamond ring. It lasts a heartbeat, and then the sky goes dark. But this window is short. NASA says the longest stretch of total darkness for this eclipse lasts just 2 minutes and 18 seconds. For most people along the path, it will be even less than 2 full minutes. 2 minutes of daytime night, and then the sun returns. And yet this particular eclipse is stranger than most, because of where it goes, and because of how long people have been waiting for it. Most total eclipses behave in a predictable way. Their shadow sweeps roughly from west to east across the globe. This one refuses to. Instead, this shadow arcs up and over the North Pole. It comes down across the Arctic and the far north before dropping toward Europe. It is a path that bends over the top of the planet, and that alone makes it rare. But the real headline is, who gets to see it? According to the European Space Agency, this is the first total solar eclipse visible from mainland Europe in 27 years. The last one crossed the continent back in 1999. An entire generation has grown up since then without seeing the sun go dark over Europe. For Spain, the wait has been even longer. The European Space Agency says this is the first total solar eclipse over the Spanish mainland since 1905. That is more than 120 years. Not since before the First World War has the sun gone fully dark over that country. Along the Spanish path, the total eclipse can be seen from cities like A Coruña, Valencia, Zaragoza, Bilbao, and the island of Palma. But here is a cruel twist. Both Madrid and Barcelona sit just outside the path. In those two cities, the sun will be almost, but not quite, fully covered. A few miles can be the difference between a partial eclipse and a total one. In Spain, the timing adds its own drama. The sun will not be fully eclipsed until the late evening, hanging low just before it sets. Imagine watching the sun go black while it is already sinking toward the horizon. Now, on that very same night, something else is happening in the sky. And to see it, you only have to turn around and look away from where the sun went down. The night of the 12th into the 13th of August is the peak of the Perseids. And the Perseids are the most beloved meteor shower of the year. A meteor shower is what happens when Earth plows through a stream of dust and grit left behind in space. Each tiny grain slams into our atmosphere and burns up in a flash. We see that flash as a shooting star. The Perseids peak on the same nights every August. But most years, there's a problem. The moon is up, washing out the sky with its glow, and the fainter meteors simply disappear into the brightness. Not this year. And this is what makes 2026 special. The peak lands almost exactly on a new moon. A new moon is when the moon sits between us and the sun, so its lit face is turned away from us. In practice, that means there is no moonlight at all. The sky stays completely dark. Under those dark conditions, the numbers are stunning. Astronomers describe a nominal rate of up to about 150 meteors per hour at the very peak. NASA offers a more grounded figure for a real backyard. Under a genuinely dark sky, they say, you can expect to see up to around 100 meteors per hour. The Perseids are also famous for something extra: fireballs. These are meteors so bright and so large that they outshine the planets, sometimes casting a brief shadow and leaving a glowing trail that hangs in the air for several seconds. The best time to watch is in the darkest hours, roughly between 2 in the morning and dawn. That is when your side of the Earth is turned directly into the stream. So, where does all of this dust come from? The answer is a giant ancient comet that will not pass this way again for well over a century. Every single Perseid meteor you will ever see was born from one object: a comet called Swift-Tuttle. Swift-Tuttle is enormous. Its solid core, the nucleus, measures about 26 kilometers across. That is roughly 16 miles wide. It is one of the largest objects that regularly crosses Earth's orbit, and it is slow to return. Swift-Tuttle takes about 133 years to complete a single loop around the sun. The last time it swung past us was back in 1992. It will not come back around until well into the 22nd century. Almost no one watching this will be alive to see it, but every year, whether the comet is near or not, the Earth passes through the river of debris it has shed over thousands of years. That debris has been building up along the comet's path for roughly 1,000 years. When we cross it, the grains hit our atmosphere and light up. That is the shower. Now, here's a detail that trips a lot of people up. The Perseids appear to shoot out from one spot in the sky inside the constellation Perseus. Astronomers call that spot the radiant. That is where the shower gets its name. But the constellation has nothing to do with the meteors. The stars of Perseus are light years away, unimaginably distant. The meteors are burning up only about 100 kilometers above your head, around 60 miles up. The two just happen to line up from our point of view. It is a trick of perspective, nothing more. And there is one more reason the Perseids are so spectacular. It comes down to raw speed. And that speed is what turns a speck of dust into a streak of fire. The Perseid grains are not large. Most of them are no bigger than a grain of sand or a small pebble. So how does something that tiny produce a flash you can see from the ground? The answer is velocity. These particles hit our atmosphere at more than 100,000 miles per hour. At that speed, a grain of sand carries a shocking amount of energy. When it strikes the air, it does not really catch fire in the way a match does. Instead, it slams into the atmosphere so hard that it compresses and heats the air in front of it to thousands of degrees. The grain vaporizes almost instantly, and that superheated trail of glowing gas is what your eye sees streaking across the sky. The bigger the grain, the brighter the flash. When a chunk the size of a marble comes in, you get one of those famous fireballs, blazing across the sky far brighter than any star. And remember the setup this year. A new moon, no moonlight, a completely dark sky. That darkness lets you see the faint meteors that a bright moon would normally hide. So you catch not just the brilliant fireballs, but the quiet ones too. Astronomers even note that a narrow ribbon of dust pulled off the comet back in the 1800s can sometimes deliver an early burst the night before the main peak. So there may be more than one good night to be out there watching. 2 great sky events then on a single night in the middle of the month. But August is not finished with us. It is saving one of its most haunting sights for the very end. On the night of the 27th into the 28th of August, the moon itself takes center stage. And this time, it does not go dark. It turns red. This is a lunar eclipse. It is the mirror image of a solar eclipse. In a solar eclipse, the moon blocks the sun. In a lunar eclipse, the Earth slides directly between the sun and the moon, and our planet's own shadow falls across the moon's face. This particular eclipse is a partial one, but only barely. At its deepest, about 96% of the moon slips into the darkest part of Earth's shadow. Astronomers call that dark inner shadow the umbra. With that much of the moon buried inside it, this partial eclipse will look almost exactly like a full one. And that shadowed part will not simply go black, it will glow a deep, coppery red. That is why people have called this site a blood moon for thousands of years. According to astronomers, this eclipse favors the Americas. The finest views fall across eastern and central North America, Central America, and South America. Parts of Europe and Africa catch it too, though for them the moon hangs low, near the horizon, close to the time it sets. This red moon also has an old seasonal name. The full moon of late August is traditionally called the sturgeon moon, named after the large fish that were once caught in the Great Lakes at this time of year. So what you are watching is a sturgeon moon turning to blood. And here is the line that tells you why this one matters. Astronomers say this will be the best lunar eclipse anywhere on Earth until New Year's Eve of 2028. So if you miss this red moon, your next real chance is more than 2 years away. But why red? Why does the Earth's shadow, of all colors, paint the moon the shade of rust and blood? The answer is one of the most beautiful ideas in all of astronomy. You would expect the Earth's shadow to be pitch black. If our planet had no air, it would be. The moon would just fade to nothing and disappear. But the Earth does have air. And that thin shell of atmosphere changes everything. Here's what happens. Even when the moon is deep inside our shadow, a little sunlight still reaches it. That sunlight grazes the very edges of the Earth. It passes through our atmosphere, all the way around the rim of the planet, before continuing on toward the moon. And as that light passes through our air, the air bends it, and it filters it. Sunlight is made of every color mixed together. When it moves through our atmosphere, the blue and violet light gets scattered away in every direction. This is the same effect that makes our daytime sky blue. The red light behaves differently. Red has the longest wavelength and it slips through the atmosphere much more easily. So the light that survives the journey, the light that finally lands on the moon, is stripped of its blue and left glowing red. Scientists call this scattering effect Rayleigh scattering. NASA puts it in the most beautiful way I have ever heard. When you look at a blood moon, you are seeing every sunrise and every sunset on Earth, all at once, projected onto the surface of the moon. All that soft red light from every dawn and dusk around the entire planet bent inward and cast onto our nearest neighbor. So on that night, when you look up and see the moon glowing red, you are watching the whole world's twilight painted across the sky. Now let me put all of it together so you know exactly what to do and when. Let me hand you a simple plan. 4 events, 4 moments to look up. You do not need a telescope or a science degree for any of them. First, the early days of August. This is your window for the Comet Temple 2. It sits at magnitude 8, so you will need binoculars, and you will need a dark sky away from city lights. Find a star chart online, be patient, and let your eyes adjust. Spotting a comet with your own eyes is a quiet thrill that stays with you. Second, the 12th of August. This is the total solar eclipse, and it comes with the most important safety rule in this whole video. Never look directly at the sun, not even during a partial eclipse. You need certified eclipse glasses, the ones built for this exact purpose. Ordinary sunglasses will not protect your eyes. Only in the few seconds of complete totality along that narrow path is it safe to look with the naked eye. Third, the night of the 12th into the 13th. This is the Perseid peak under a dark new moon sky. For this one, you need no equipment at all. Just get far from city lights. Lie back. Let your eyes adjust for 20 minutes and watch as much of the sky as you can. The hours after midnight are best. Fourth, the night of the 27th into the 28th. This is the blood moon. Again, no equipment needed. It is completely safe to look at a lunar eclipse with your bare eyes. Just find a clear view, ideally toward the horizon if you are in Europe or Africa, and watch the Earth's shadow slowly swallow the moon. 4 events, 1 month. A comet, an eclipse of the sun, a storm of shooting stars, and an eclipse of the moon. And most of it visible from your own backyard. So here is where we stand. In a single month, the moon will blot out the sun over Europe for the first time in 27 years. The sky will fill with shooting stars under perfect darkness. A comet will drift past in the background, and the moon will glow blood red one last time before hiding away for years. None of these events knows about the others. The comet, the moon, the meteor stream, they all run on their own separate clocks. It is only by chance that those clocks happen to line up this August. That is what makes it rare, and that is why it will not repeat for a very long time. The universe is not putting on a show for us. It never is. It is simply doing what it has always done, on a scale so vast that a human lifetime barely registers. But every once in a while, the timing bends in our favor, and we get to stand under it and watch. This August is one of those times. So mark the dates, find a dark sky, and when the moment comes, put the phone down and just look up. If this helped you understand what is coming, subscribe, because I will be here for every one of these nights, breaking down exactly what you are seeing. Until then, keep looking up.